Okay, hello everyone. Welcome to another Wolfram Language Design Review for version 15. And let's see, we had started on this. Where had we got to?
Yeah, so last time we started, I think the main discussion was on graph value plot. And so we updated the design.
Okay, good.
And the next was after start to look at accelerator and the rest of the.
Okay, but did we look at we looked at tag nest graph and things, right?
Yes.
I want to use that function. I have a use for that function like today. Means I have to switch to using version 15. Okay.
So
Graph value
your
plot.
ref page is a little old. I made a
Oh,
commit this
should I
morning.
update it?
Yes, please.
Can you remind me what the design change this has to do with how to render the different kinds of ways to indicate values on a plot? Is that correct?
Yeah, it was more in the specification where the emphasis was more about the actual values.
Okay. But I mean, we have size, we have color, we have other things as ways to
Yes.
indicate.
Yes.
Okay, so what's happening here?
So the
Vertices V sub I. What are the V sub I here? They're vertices in order, right?
Yes.
yes.
So I don't understand this. I mean, I would have expected that I could also give a list that is of the form V sub I goes to value, goes to styling. V sub
Uh,
I goes to the styling.
Yes, which is the third specification, where we use WI to say both vertex and edges. So you can do V
I
of
see, but
5 goes.
why is there? I'm very confused. If what is okay, what is enc?
Encoding.
Okay, but so okay, so this is showing. So this has a the equivalent of a color function scaling. Is that correct? How does
Um,
that work?
yes, so from those value, like you say, we find the vertex style, so the color function, as well as the vertex size.
How big can
And
it get?
the values,
No, how big can, I mean, like if I take this, I see. And there's no scaling function concept. So if I take that and I put, then I have to just do myself. Wow. Okay.
right. So that was actually, you see that at the end of the stuff, the option and such, there were so many scaling functions that we decided at least this time to first hold on and figure out how to present it, because you want a scaling function for the color, for the vertex size and such.
Now what just happened there? How do you deal with those?
I mean, if you use color, you need a legend. How do we get a legend?
Well, I understand, but I think negative numbers, it would be nice to have a color map that goes, to the positives and to the negatives, because that's somewhat understandable. Am I making sense? In other words, you can use the size as the absolute value and the color as the sign.
Okay.
Is Tim or somebody here?
Yes, because actually that color function, unfortunately, is not. He went to lunch, but that call we work with Tim on the actually finding the
Should we
white
see if
color
we can
function.
get Tim here? Tim isn't here, is he? Could somebody try and get
Do you
Tim?
want Tim?
Yeah, please.
Shadow power?
Yes. Okay, that would be my suggestion, right? That we
Right,
encode the sign. Now, what happens if I have, I mean, I'm just going to be mean here, but what happens if I put in, it just kind of went splooble.
Well, in some
Nice
cases,
to-
we just disregard, right? We don't want to really fail.
Why, that's probably that node there.
Yes.
Okay, that wasn't good behavior. I mean, it should give a message. Am I making sense? Not obvious to me that it should give, I mean, I think it should give a message and then pink that vertex somehow. Am I making sense?
So we still draw, but we ping the vertex.
That's what I'm suggesting.
Okay.
Or actually make it bright red if you want to. I mean, I don't know, something, but no, maybe not red because people use that. We could pink the vertex and make it some generic, mid-size of the vertices. Am I making sense?
Yes.
Okay, whatever you want to do for that case as well. There's going to be a nice function. Okay, let's keep going, understanding what we're doing here. So if I say here, okay, so now the vertices are all the same size. But if I say here, vertex color and vertex size,
That's, I mean,
we don't yet take that.
How are you going to do that? Because otherwise it's dead in the water, right? You want color and size, because that's what you're doing by default, right?
presumably you can do more than one.
Yeah, we kind of put them in a list separately. We don't.
I see. So what you're saying is that what I'm doing is I'm saying I'm basically does this
Maybe.
work? Doesn't work, does it? Something like that should work, shouldn't it? Well, anyway. Okay.
You have too many. You put in kind of garbage.
I knew I was putting in garbage, but I don't know.
Okay.
Okay, I think it's reasonable. I mean, but for goodness sake, give a reasonable error message in the other case. Am I making sense?
Yes.
That doesn't look right. Something got cut off there. Well, now what does vertex label do?
So we just apply those values to the labels.
Why didn't that work? Don't tell me I have to give the number.
Yeah, that should work. In principle, we should be able to truncate and align that. So
yeah. I mean, what I don't like here at all I should be able to say 2 arrow A, 3 arrow B, right? Is this correct that I can do this?
Yes, but the other way around. So what we do
It
is
shouldn't be the other way around. It shouldn't be the other way around, because this is what you do if you say vertex, style, arrow, whatever inside the graph, this is the way you do it. It should not be the other way around. Do you see what I'm saying? In other words, if you've got something, the alternative ways to do this are you specifically give these colors, vertex, arrow, specification, like for size, for example.
yes, I understand, but the key idea is that the left-hand side are not generally the option, right? I mean, in this case of vertex label, vertex size, they match, right? But we don't have vertex opacity as an option, right?
I know.
And also when
Charles,
right.
it doesn't make sense. You've
Okay.
got to be able to have something where it says vertex, arrow, value, not something where that's been taken apart. Right? Labeling
Right.
what to do with the vertex, arrow, value, that's a separate thing. Do you see what I'm saying?
Yes, yes. I was just trying to point out that we went more in the direction that we assume people will give more encoding. So that's why we went from vertex to
I don't think
encoding.
it's the right thing. I think this is going to be a super common thing. I want to indicate just 3 nodes here in a particular way.
Okay. Yep. And adjust that.
Okay, so let's just check that this is the right way around. That we don't want to say vertex, this thing, arrow vertex label. Do you see what I'm saying?
Yes.
It seems more natural to do that. Because the generic is just graph value plot like this. And if I now say this, I don't know what people say about this, but it seems to me more natural. I don't know what we've done in other, we have Brett here. Do we have Brett here? Do we get Brett, please?
Yes.
I don't know what we've done in other functions. Roger, can you speak to that? But this seems somehow a little bit more natural to me.
The things that are similar, kind of highlight graph, highlight image, but they don't have values. What they are limited to do is to just say what and then how,
Right.
but not what value how.
Yeah, but this is something we're going to want to do in other visualization.
No, we are going to want that. And
I'm pretty sure this is the better way around. Not absolutely certain though.
I mean, we usually have wrappers like labeled or call out and things like that.
Yes.
And they are not infix, so to speak.
Well, but labeled is a wrapper around. I mean, that's an alternative kind of thing that we could imagine is something like this, where we go, but that's really just taking over a vertex style, right?
Yeah.
There's no reason to do that.
No, I think the value is the kind of, you want to plot. It's a way to want to plot on top of the graph effectively.
Yeah.
That's what I think way we should see it.
Right. Which is why this is important. Right. So in other words, if the graph has and it's also possible we should support the case, 2 comma A. If you're really plotting on top of the graph, you've got, the graph vertex names, and then you've got the values. I don't know, maybe let's not do that initially. Charles, you see what I'm saying? I mean, if Roger is right, that what we really want to do, let's say we say, graph value plot of complete graph of 20, and then we say table, x square root of x x0 to x to 20.
Yeah.
And that's really plotting on the graph.
Yeah. And that,
Right.
and that's a super, I mean, even from our own compute functions and so on, that's super common. And I'm sure you
I
have
agree.
other
I
derived
have
things.
zillions of cases where I want to do this.
Right.
And where I have, I mean, zillions, and I have it written out in terms of vertex style and so on.
Right. And this just automates a lot of the workflows.
No, it's very nice. But by the way, I don't think the borders should be that black here. Is this out of graphic design? I mean, I'm not wild about these colors
No.
either.
Yeah, well, the principle here we decided to do was unless specified, we don't change the layout. So we use the default layout and we use the existing styling. So complete graph, and most of our graph have an edge form by default. So we just decided not to start to change
I'm
the
not sure
default.
that's the right decision.
Okay.
But I mean, let's see what happens with different colors here. Did we find Tim?
No, not yet.
Tim
See if we can find
But Brett is
Tim went
here.
for lunch. Brett is here. I think should be here.
Do we want to discuss this colors, or is that a separate meeting?
I vote that it should be a separate meeting. So we went
Okay,
one
all
time
right,
with
fine.
discussing with
Maybe we can put it into that graphics review meeting.
Graphics improvement. That's fine. Okay, but let's make sure we do it. Okay, now, what happens if I have a weighted graph and I want to indicate the weights somehow? Is that a thing here?
So if you have a weighted graph, there was the one of the spec at the end where you can actually, that second argument, you can actually give the name of the edge weight or vertex weight.
I don't understand. You mean from an annotation?
Yes.
Yes.
The annotation name.
Okay, so hold on. Let me understand that. I mean, a generic weighted edge is done how in the graph? I don't usually, it's weighted.
So if you build, like you take the complete graph, you can do, edge weight, and then you get the value of you give the weight. So the complete graph.
Then what?
So if you do comma, edge weight
That's
goes
hard.
to.
Edge weight goes to what?
And then just.
It's
Yeah.
what is 20 times 19 over 2 or something?
Yeah, right. But I mean, in what order are they given?
Well, in standard order. That's why it's hard.
So we have edge index, which map exactly the standard order.
What do you mean edge index?
This
So
is
when
standard
you build
order for edges.
the same for vertices, right? We have.
Okay, so I could just give random real 10, comma, 20 times 10 times 19.
Right.
Okay. Now, how do I show those edges? Well, how do I show the weight?
You can do comma, edge label goes to edge weight, for example. We will try to put.
Okay. But what about if I want the thickness proportional to the edge weight?
So use graph value plot. I mean,
That's what I wanted to do. That's what I wanted to do. That was why I was doing this here.
Right. Okay. So do graph value plot. And then say, do you have edge thickness arrow? Edge weight.
Edge weight in like this?
Yes.
Now, what happens if I want a smaller edge weight? Because this is obviously not going to work.
So we don't have the scaling function yet, right?
Okay. But how are we going to put in the scaling function? Because there's scaling functions for each different parameter. So I think we're going to have to go to an association syntax in general. Am I making sense?
Yes. So
Because otherwise you got to have a separate scaling function for the thickness, the color, the this, the that.
yep, exactly. So that's the current issue we are trying to
Well,
figure out how to
I
do
would
that.
make an association as a general thing, and I wouldn't worry too much. I mean, and if it finds out that we have a single, we can have a single sort of switcher, then so be it. Okay, but I want to come back with Brett to this question here. So here, right now, the way this is done, Brett, are you paying attention?
Yes.
Well, it's kind of a vertex size, let's say. I mean, by the way, another reason to have it postfix like this is to avoid the confusion of is it vertex size in quotes or vertex size as an option. Do you understand what I'm saying?
Yep.
Also, I think that negative number thing just didn't work out very well. Again, if you just specify vertex size, it should presumably just use the absolute value. Do you agree?
Yes, we can change that.
I think that's the right thing to do.
I mean,
I can
can you put the
half a
absolute
dozen
value?
things you could do. So
Can you put the absolute value? I thought it was what we did. But
No.
it's not. No, it's not.
Is it the right thing to do? And is it consistent with other visualization functions? I mean, if I do it with an array plot, what the heck is it doing?
that's absolute value.
It's absolute value.
Okay, then we should do absolute value here as well. But matrix plot wouldn't do absolute value, correct?
No.
Correct. Matrix
sure
plot
not.
has the orange-blue
And
signed
it also
color function.
it also knows complex, and it also knows huge range of scales.
Okay, so we should
Yeah.
obviously use the matrix plot idea in graph value plot. Because the default should be exactly this, and possibly even the same colors, to indicate positive and negative values.
It also knows things. It also thinks specially about zero, because you have sparse matrices, which are mostly zeros. So you want to see the structure.
Let's talk about that for a second. But first of all, do we agree on the first point? Let's reuse the matrix plot idea for graph value plot.
Can
Yes?
you make one of those values in your matrix 0?
Yes. It'll be white.
It will be white, which means that you will get a white
No.
vertex.
I'm not saying, guys.
Oh, sorry, I thought you were saying use exactly this color function.
Okay. Use the main ideas of this color function.
Okay.
Charles, does that make sense to you?
Yep. Yes.
I don't know quite what that did. Real part, probably. Now, let's talk about the zero case here. Okay? A zero-sized vertex. I mean, let's see. If it was purely by color, I think having a zero be white is just fine, right? If you purely said vertex color, am I making sense? Do you understand what I'm saying?
Keep going, because
Right.
you're going somewhere with this, which may or may not
okay.
make sense.
Okay, so the question is what to do with the default. And a default zero vertex, in my opinion, should be just a minimal joining of edges. Am I making sense? Because in the default case, we're using both color and size to represent value.
We
Right?
are?
I think you are.
Are
When
we?
you give yes, when you give the
So we
the
double
second-
encode it.
Yeah, when the second argument is a
So we
Yeah,
double
here-
encode it.
Yeah. Right. That's what that's doing.
Mhm.
Color and size. So what I'm suggesting is that we do that. I don't know whether it's a square root size. It presumably is. Yes, Charles? The area is proportional to the value, correct? Make sure it is. The area should be proportional to the value. Am I making sense? Just like for bubble chart.
Okay.
Or any other technology that we developed for bubble chart we could reuse here.
Well, but the key issue is that, I mean, the default, or most of the time, the vertex is not just a disk, not just a bubble, right? So that's
For what? For a graph?
Yeah, people have different vertex shape
Sometimes
function.
they do, but most of the time they'll just be circles.
Okay, we will run that. We run several experiments for different vertex size, and we end up with this one, but we will run that.
What is this? What is this function?
The underlying function essentially do a rescaling plus a minimal value.
Okay, but is it linear? Is it rescaling? Is the
Yes, it's
area
linear.
going up like the square? Or
Is
is
it
the area
is
going
it the
up?
diameter is linear?
The diameter of what?
The disk, or the radius of the disk. Is it proportional to the value?
Yes, it's proportional to the value.
Okay.
That seems wrong.
So for bubble chart, we support both, because we couldn't settle the debate, to be honest.
Well, what's the default?
Default is square root. It's area.
Yeah, the default is square root.
So we should do the same thing here, I think. Is there a reason? Is there a problem with that?
I want mine, but it's at the end is aesthetically pleasing. So we will run some tests and see if it look better than the default one.
So I assume that when the number of you should also make it so when the number of vertices increases a lot, that you reduce the sizes so we don't get the overlap craziness. Am I making sense? So for example, this thing here shouldn't happen. Right?
Yes,
that should have rescaled, automatically rescaled the thickness. Does that make sense?
Yep, we do that definitely for the vertex size. Yep.
No, I understand. So it just needs to be done for the vertex thickness as well, edge thickness as well. Okay, so just going back through this, what I'm saying is, by default, I would use color to indicate positive and negative, and to indicate, intensity somehow, and color and size. But then the positive and negative, just like for matrix plot, could use the same kind of rough color palette, maybe. I don't know if that color palette will look good. Maybe too bright. Does that make sense?
Yes.
Come on, guys, you got to say
no. Yes.
something.
Yeah. It makes sense.
Okay, so just respond, please. Okay, good. Okay.
Just taking note and then also making sure that
but hopefully notes are being taken separately as well.
Yeah.
Okay. All right. So let's look. So I wanted to ask Brett, this approach of saying you've got these values, this is what to do with the values, putting a postfix thing there. I want to know whether that reminds you of, is inconsistent with, is consistent with what we're doing in other visualization functions.
So the vertex opacity there is one of the encodings, correct, Charles?
Yes.
Yes.
Okay. So then I'm just looking. Where did I have that?
Well, I mean,
right. So point value plot, is a little bit different, but also in the case where you have the rule syntax, the encoding is the right-hand side of the rule. So, thinking of it as we're taking these things and displaying, and representing them as opacity.
Where is that? How do I see that?
It's farther down. It's right above the option table.
Above.
No, it's not.
Above the option
table.
Right.
Okay,
I mean,
but
and so
that's a little different, isn't it? I mean,
it is a little different because the values are more tightly associated with the data. So you wouldn't normally have the 1, 2, -3, 4, etc. On the left-hand side, you would say, position 2 in my list of metadata is going to
why did
be.
that have a delay? Sorry, why did that take time to run? Why wasn't that just instantaneous?
Run it again.
I didn't see it,
Run it
so
again.
No, it'll be instantaneous second time.
Yeah.
I'm just wondering
So
what's happening.
some loading problem.
Okay. All right. That's not the most beautiful choice of plot range that I can imagine. And I'm also very confused why there's a 1.0 or whatever. The plot range for point value plot could have a bit more headroom. And by the way, I want to talk about headroom for list plot.
Okay.
Not right now, right?
Not right
No.
now, but not right now. But can we add that to the next graphics improvement meeting?
Yep.
Okay, but I do think that we could talk about this in graphics improvement as well. I think this needs a bit more. For some reason, this case, maybe I'm wrong.
I mean, it's very tight on the right-hand side to that green point as well.
No, it's wrong. It's
yeah.
wrong. Something is wrong here. Okay. Okay, but be that as it may.
Right. So if you turn the red and green into pairs of numbers, for
Pairs of
example.
numbers? Pairs of numbers, okay.
Yeah.
Okay.
Yeah, so by default it's going to do something. Probably little pie charts. But you can then say as the second argument, 1 goes to color, 2 goes to size. And so
That's very different from how graph value plot works, because graph value plot, this notion of vectors of values is totally missing from graph value plot.
Yes.
Let's just think that through for a second. I mean, wouldn't that be useful? The problem with graph value plot is the numbers are coming from vertex names, and vertex names aren't, there's no particularly natural way to have them be lists of things, except that the annotations could be lists of things. So you could imagine that annotation 1 goes to color, annotation 2 goes to size.
Yeah, and custom things. Yeah, so that is custom things. But let's say that you have a bunch, maybe your vertices are complicated. You have a bunch of things you want bunch of values. And
well,
that's not atypical for, we were thinking of point value, we're thinking of geo, right? So a point might be a city or a country.
We're not really thinking of geo. We're thinking of all kinds of things.
No, for point value plot, we were thinking of geo. That's where it came from.
It was thinking of spatial.
Yeah, well, spatial statistics. That's where it came from.
Okay, but I think it's useful. I haven't used it very much because I didn't remember it existed.
Mm-hmm.
But I think it's useful for all kinds of purposes.
I agree. But the reason
wherever it comes from. Okay, whatever.
Okay.
The issue is, how do you take in a graph value plot? How do you take one annotation, encoding it one way, another annotation encoding it another way? Is there a syntax for that right now, Charles?
Yes. So from our design, you can, if you have a vertex 1 with a, annotation 1, right? So you can
No, I'm not taking vertex 1. I'm saying all the vertices have some annotation. So I mean, for example, the obvious thing to be able to do would be to say,
then in the second argument there, you can put the name of the annotation like edge weight or vertex weight.
1 goes to vertex size, let's say, and 2 goes to edge thickness.
Yep. Right now, we have that exactly with the other way around.
Except it's the other way around because of the.
But one thing also to notice, I'm not insisting on that point, is that one advantage in graph usually is the ability to do patterns, right? By
Yes.
flipping this, you can't do patterns, I believe.
Why?
How are you going to specify the vertex or
Sorry,
the
I mean,
edge?
what do you
Normally,
mean?
we match the left-hand side of the pattern, not the
I mean,
right-hand
what kind of
side.
pattern are you imagining? I'm not quite following.
The same like you do, vertex, the normal graph, vertex size, V underscore, and then you associate the pattern. Exactly that.
Okay.
So you can easily define a function or manipulate.
But you can do exactly the same thing here. I mean, this is because you're saying there's an encoding. Yeah, it's exactly the same, right? Because what you're doing is you're saying this thing here, V blank arrow V squared or something like that. That whole thing, arrow vertex size. Now, I think you have to parenthesize it, don't you? Yes, you do. You have to parenthesize it. But you have to parenthesize lots of these things. Incidentally, could somebody add this to the user assistance meeting, a flash, just like we have for flash for this case.
Mhm.
Okay, just like we have for ampersand now.
Yeah.
Just so you know how it grouped. Okay, but I think this will work, right, Charles?
Yeah, different than my usual, but yes, we will work it. We will have
Why is
to
it
go.
different from the usual?
We didn't have
You-
value
you-
in the usual, Charles. We just have a
No,
list
but
of
usually when I detect a rule, is the left-hand side of the rule we define the pattern, right? And
This is the left-hand side of the rule. It's right here. It's just not the left-hand side of the whole thing.
right, we can make it
It's
work.
fine. Yeah.
We will make it work.
All right. I think we've gone through lots on graph value plots. I think that's okay. The scaling stuff, we got to have a good default to begin with. And then why don't you try and make up the full association syntax?
Yep, we'll make that.
Sandra on our live stream is commenting on some issues. Bubble chart. Oops.
what?
Why is bubble chart blue?
Is that not a real text? Is there something weird in that text? Yeah, there's something weird in the text.
Something topic actually. So the -1 just got ignored.
Right. It doesn't.
That is arguably not correct. I mean, arguably, whatever we do here for graph value plot, we should also do for bubble chart for negative values. Like encoding the negative values with color in bubble chart would be a reasonable thing. And then
we have different data sets. I mean, it's like a list plot. When we have different data sets, they have different colors.
I see. Well, we could still have a different color. We could have a multicolor version, multicolored. I understand what you're saying, but we could still have the positive and negative for each data set. We should look at bubble chart and we should try and make it consistent.
I mean, we could add more. I mean, so generally, we can add more encodings. Like we haven't used filling as an encoding yet, for instance. There are many.
Right. Okay, fair enough. But I'm just saying there's a consistency issue between bubble chart and graph value plot. So we should fix that. And Tim, we were talking about colors for graph value plot and maybe following a similar pattern to matrix plot, although I'm suspicious these colors won't work that well.
Okay.
All right. Any more to say about graph value plot? Graph value plot is going to be a very powerful and useful function. And I think.
Yeah, I mean, I think we've felt the need for it for years, so we know it's been built up with internal needs for sure.
Well, right. I mean, I've built this function basically many times.
Yeah,
Now,
me
I just
too.
want to comment on the discrete case, because remember, vertices, you can't use the vertex name. If you've got three discrete things, triangles, squares, something or others, the vertex names are unique. Every vertex name is unique. So if there are three different, it's not like there are three different vertex names and you get to use those with different markers. The vertex, you get what I'm saying? So I don't know why that makes sense. I mean, it does make sense if you're using an annotation.
I think discrete makes a lot of sense if you have, let's say you have two types of vertices, like in a pattern net, you have transitions and you have um, what the hell are the other ones called? The non-transitions states.
States, I think. It's very
Okay.
confusing. It's the wrong way around, the naming of that. But
Right.
anyway, it doesn't matter.
But there's like two types. So there's
It's a
a few.
bipartite graph of some kind. We have them in token event graphs all the
Right.
time. We have
But
tokens, we have events.
But there are many graphs where there's only like a few types, and that's what those discrete things are useful
Yeah,
for.
and essentially for grouping, right? So
Yeah.
No, I
community
know,
graph
but
plot and
that's where
such.
you use a pattern. So, for example, for a token event graph, I've endlessly had, vertex style is defined by the pattern, token
I
goes
see.
to blah, blah, blah,
So you're
event
kind
goes
of
to blah,
doing
blah,
it
blah.
you're rolling that with the
Yes, but I mean,
existing
but
functionality.
that's the typical way I'm doing it, is that the
Mm.
vertices, it's not, because remember what you have is, let's say E is an event and T is a token. It'll
Mm.
be, token 1, event 7, that kind of thing, right?
Mhm.
So there's an annotation in the name of the vertex, but
Mhm.
the name of the vertex isn't just, so what you'll have to do is E blank goes to,
Right.
I mean, so that'll be E blank goes to 1, well, no, E blank goes to, and this is where it's going to get tricky. Okay, so this is what you're going to want to do. You're going to want to say E blank of I there goes to, this is a bit of a mess. Hold on. Oh, I see. This is what we would do. Let me just see if I can write it out. E blank goes to, now at this point, I would just like to say yellow or something. See what I'm saying? And T blank goes to, standard blue or something. And then I would like to say, then I would like to say, let's say, blank of I blank goes to, I mean, the syntax is getting tangled up, but goes to vertex size. I mean, the syntax got tangled up, but you get what I'm saying.
Because you encoded things in the name.
Yes, which is going to be a pretty standard thing to do. I mean, the alternative is to encode in annotations, but you're not going to want to do that because lots of operations that I do in these graphs depend on what type of vertex this is. I honestly don't even know how to do it with annotations. Well, the question here is, in graph value plot, should you be able to directly give the actual style to use? Probably not. Probably you don't need that because in fact in the graph, if I'm not mistaken, well, how do you do that? Can you do that? Go ahead.
I mean, you don't need to do that because you can always do that with vertex style, right? But also what we did is I think we are forgiving enough that if we detect that you are giving color instead of value, we use those color for the vertex encoding.
Yeah, there's no value here. Right.
So it will work. But
Sorry, say it again. Excuse me, I got distracted by something.
I say, in this case, somebody can directly just use vertex style. But in graph value plot also, when we detect that the value are color, not just numerical value and such, then we understand that you want to actually encode that value, that color, to the vertex color. So we support that implicitly.
Okay.
On the other hand, since you have these encoded vertices, mapping them to values is kind of super easy, actually. Sort of vertex list and then apply your functions like 0, 1, or whatever you want.
Sorry. Was distracted. Could you say that again, please?
I say, if you have things encoded in the vertex name, it's actually kind of pretty trivial to get values, because you just get the vertex list and then map your function over it, map to values.
Yes.
It's just
but
two
the problem with
values.
that is that you end up with the thing where you say, graph value plot of G. So long as you've named G, but if you I have this code all over the place. I say with G equals graph blah 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 blah. Then I say something G comma blah 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 G. You see what I'm saying? And that's kind of awkward, but it's okay. I mean, we've crossed that bridge already. For vertex label, I assume that will use the actual name of the node, right?
Yes, it's just the illustration, yeah.
What's this edge bundle?
Oh, so it's this the same like we did in community graph plot, essentially for a group of edges which have the same value, then we bundle the edge, those edges.
Does that work? Do you have an
app? No, not that one will be futurized. We are still working on it.
Yeah. I mean, it's an interesting idea, but you never know if it's going to work or not.
Let's iterate this.
It worked for community graph plots, right? So
looks nice in community graph plot.
It does.
What the heck is this?
Those were the new, and I think you reviewed them last time and you like them. Those were the new
highlight colors. Yeah, I do like them. Okay, all right. I've got to go to something else real soon here. Do we want to have a quick look at this? We're going to need to come back to graph value plot. I think needs a little bit more iteration. And I mean, it's close. Should we take a quick look at this?
Yeah.
Yep.
So what's just a quick summary for you to get your bearing. And so we keep expanding this in along two different dimensions. One is more functions, more Wolfram language functions have GPU and other accelerator support.
Yep.
The other direction is to support more kinds of GPUs.
Yep.
Okay, so both of those have happened. And now there's a third thing, which is what we call hybrid. This is something that is smart and optimizes, sometimes combines.
Which is what the automatic method should be.
Yes, but we're not there yet. But yes, that's what it should be. We are introducing it now, but it will at some point be the automatic method.
I don't think we should use method option for this. I think that is overloading the method option. I think we should say target device arrow, whatever.
I mean, was a hybrid CPU GPU is a target device?
Why not? It's GPU is a target device. Why can't that be a target device as well?
But yes,
but now we're going to have to add new target device options everywhere we want to do this.
And how are we going to merge between method and target device if somebody?
Many methods are not available, by the way, for these
devices. Will never be available.
Will never be available. Yeah, you're right. They will never be available.
Well, look, the point is this is going to be automatic anyway.
Yes, at some point.
Although I still don't understand the scheduling of GPUs on computers. Is it a solved problem, or is it still a mess?
And by schedule, you mean in terms of priority of use?
Yeah, I mean, if I have look, if I do a parallel job, I got my computer. It's got a GPU, right? It's got some number of CPU cores. I have no idea what's happening with GPU cores. Is it one GPU core per CPU core? I don't think so. I think there's one GPU. I don't know how it's architected. Do you know?
Yeah, so roughly speaking, the CPU or the process will use the GPU available. So it will use all the available GPUs, pretty much.
I don't think the operating system is scheduling anything on the GPU.
The GPU, exactly.
How does it work? Is the CPU feeding it out to a pet GPU, or what's it doing?
No, so essentially, each GPU have a queue for executions, right?
Yes.
So the process actually submit the request to that queue, and whatever is in the queue get processed. So if it happened that in your GPU machine, we overload it with our GPU array, and then the front end want to use it, it will probably hang.
Yeah, I know. That's what I'm
Right,
concerned about. That's why I'm bringing this up.
I mean, it's not too far from the behavior on the CPU too. Right? So you can overload your CPU and take all the threads, your machine will slow down. That's why we end up limiting the number of CPU we use by default for parallel computation, or multi-threading, I should say.
No, I understand, but we're sort of hacking a scheduler there. You know, we're doing a very primitive form of scheduling there.
Not per se us, right? We submit it to the.
I know, but we're avoiding overloading the queue by doing this thing of reducing the number of threads and so on.
Right. So this, yep.
Right, but I mean that's a fancy operating system. I just don't get how this is being done yet. I mean, I assume that Apple is the one most likely to solve it because they've got integrated GPUs.
Even on Apple, it's still happening, right? It's still
okay.
I can easily overload my.
Okay, design-wise, I mean, clearly GPUifying things is, highly worthwhile. But why is this a method option? I mean, aren't there things where there's a method option for, I don't know whether there is one for linear solve, but there might be one for, I don't know, some optimization method. It's genuinely a method.
But fundamentally, this is actually genuine method because it's in a specific algorithm we're implementing. We just use two different hardware. It's an actual method. It's just that we decided to not give a obscure name, and then we just call it hybrid CPU GPU.
Linear solve has many methods, Stephen, by the way. And when you start to load it up and when you start to push the limits of it, you become aware of them. Like if you solved a lot of FEM problems, you would probably start to become aware of it.
Right. Listen, I'm getting distracted because I have something else I need to do. I mean, we're going to have to come back to this.
Mm-hmm.
What's that? Maybe that example I would understand. Can we use, does the cellular automaton function use GPU array?
Yeah, so these are some example of compute on them. So we don't have yet a cellular automata who generate a GPU array. That can be a project. So this is more.
So what the heck are we doing?
Well, I would just summarize. I didn't read the beginning of the example. What is it doing? I mean, what's the?
It's just taking the output from cellular automaton and computing difficult functions.
Oh,
like
analyze the
mean.
statistics on top
Yeah,
of the
Right.
very
result.
exciting.
Okay,
Yeah.
okay.
Seems like
Okay,
a
I
waste
get it.
of time, honestly.
We are just writing example to show the performance difference while we use GPU array compared to that. And this
Right.
is
But this is just a way of getting a large number of zeros and ones.
that's one way. Yep.
Right. But I mean, it can't be efficient to move that stuff into the GPU and then do the computation. You might as well just do the computation on the CPU, mightn't you?
No, this GPU is actually faster. The cost of actually moving is cheaper in this case.
Okay, that one should be good. That one should be quite good. So this is all on the GPU? Oh,
yes.
no, you had to hack it. You had to hack it here. What's this?
I don't remember all the detail of the code I was reading, but essentially was constructed using GPU array. Yes.
I understand, but look, it's got some weird hack here. You know, if you tell me I just put the data into a GPU array and then I do these same functions, well and good, but you've got a strange hack going on here. Am I making sense? Look at this. It's got some strange hack there. It's not just this. Right?
Right. It's just too different. I think in some of those examples are just
no,
showing
it's because those functions don't work with GPU arrays. Let's call a spade a spade.
Which functions?
You know, and the fact, look, you're using append to here. You know, this is using nest list with listability.
I agree. What I'm just saying is that in several of these examples too, we just showed two different implementation, right? Nest list, one case, append
but does
to,
that work
do
with
loop.
GPU arrays? Does nest list work with GPU arrays?
Well,
that's what I'm asking. I should be able to take
if
this.
the function f work on GPU.
You can see the function f. It's this. That's the function f.
Right.
Now, did that work on the GPU array or not?
Rotate left, rotate right, division plus and fractional part. Yes, they work on CUDA version of GPU array.
Okay, so then why did you write this with an append to that looks like Fortran?
We can remove it. It's just an example to show demo. There's several cases where we want to use a compiler and such. I don't remember exactly the detail why we have it. Right.
Well, don't do it. Unless you're trying to write low-level code and you're signaling you're writing low-level code because you've got type specifications, all kinds of weird stuff, which I suppose you do in this case.
Right. We will fix that.
Okay. Reminds me, numeric array, what is it supposed to do?
It was introduced to be a numeric array.
But I mean, does it have operations that can be done on
No,
it?
so I think we should return to that when we work on arrays. So it got taken over by Mark Sofranio in the runtime library, I think, and then disabled all operations more or less.
What do you mean disabled?
Yeah, I think you can't do operations on it.
No,
basically.
I understand, but was that because nobody built them, or is that because we chose?
They were built, but Mark thought they were built the wrong way, so he disabled them, I think.
Well, the thing,
can we have that, please, in a meeting soon about numeric array? Can we add
if you want to focus on that, I think you should wait until we can focus on arrays and we can really solve it.
Oh yeah, I want to know what happened because what you just said didn't make a lot of sense to me. So how about we just bring that up in an LCC meeting? Carla, could you please add that to the agenda and just let's hear about what happened?
Yeah.
All right. I think this is going to be a separate meeting, but this looks a bit messy to me. I mean, it looks like one of these cases where only if you are one of the druids do you know that, oh yes, this particular case with this particular function done in this particular way works with GPU array. Otherwise, forget it.
That's why when we are adding the automation and that's why we are spending the scope, that things just work automatically. It's part of that process. I think this is
great,
just the beginning.
But I don't know how far we can get because this is a thing that we had problems with the compiler for a decade on. And we had problems with lots of these different things. In other words, unless there's I guess in this case, there's a simple fallback. It just uses the CPU.
Yeah.
Right?
Yes.
Yes.
Well, that's okay, I suppose. I mean, it's great to add more GPU support, no question about it. Okay. Anything else that we should go over right now?
I think you've been through the whole agenda. Do you want to return to this, or do
I
you want
would
to do?
like to. Yes, I would like to. If we can, you know, and maybe when we go back to graph value plot, we can also cover this a bit.
Yeah, I mean, we should schedule one more meeting, probably
That's fine.
whenever they want to schedule it.
Okay. All right. Sounds good.
Okay.
Okay.
Lo-